everyone, it's Alyssa and welcome to You Can Learn Math. Today is about arithmetic sequences. Arithmetic. I know it looks like arithmetic, but in this particular context we say arithmetic because we're very fancy that way and we're very posh and we say arithmetic sequences. A sequence is a chain of numbers that follows a pattern. An easy way of looking at it. Like this would be a sequence. This would be a sequence. And they continue. In this first one, something is being added each time. This time, in the second one, something is being multiplied each time. If something is being added or subtracted, that is an arithmetic sequence. If something is being multiplied, it's called a geometric sequence, and that's a discussion for another video. This video is just arithmetic sequences. Geometric is next on my list. When I get it done, I will put a link in the description below. So an arithmetic sequence is something is being added each time. For example, here, 3 is being added each time. 1 plus 3 is 4. Plus 3 is 7, plus 3 is 10, plus 3 is 13, and so on. And this can just go on forever. And it can be any number. It can also be, it really just doesn't want to move. Fine, whiteboard, I'll clear you off. So there, not the boss of me. All right, and it can also go down, so it can be subtracting. It can start, let's say it goes down by 3. 1, -2, -5. It can go down. So you could say we are subtracting 3 or even adding a -3. Either way, same difference. So that's what an arithmetic sequence is. The same exact thing is being added or subtracted every single time. Now, if you have that sequence and like if they give you the first ones and say, okay, 2, 5, 8, 11, what comes next? You might go, okay, 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. And that's great. But what if they gave you this and they said, okay, 2 is the first number in this sequence. What is the 50th number? You go, oh my goodness, I'm going to be sitting here pressing plus 3, equal on my calculator 50 times? No, there must be a better way. But yes, hypothetical person, there is a better way, and that's what we're about to do. Actually, I don't want to clear the canvas. All right, so what is the 50th number? Here is the formula for this. I'm sorry if I sound a little stuffy. I've got allergies, and it's messing with me. Okay, so here is the fancy schmancy formula you're going to see, and I know it's going to look a little like, what is going on? I was just adding 3 and it was so nice and simple, and what are you doing to me? Okay. In this context, it's also almost supper time, my stomach's gurgling. I am just making all kinds of unprofessional noises here today, aren't I? All right, so in this context is talking about the number in the sequence. This n, if it was 5, it would be the 5th number. If we put 7 here, it would mean the 7th number in this sequence. If this was 11, it would mean the 11th number in this sequence, and so on. So what this formula is saying first is if I want to find a given number in a sequence, I have to know the first number, at a sub 1, that's how we say that, a sub 1. Then I take the number of the sequence, the number, like in this case, the 50th number, I subtract 1, and I multiply by d. d is the difference. In this case, up here it is 3. I'm adding 3 each time. Okay, so again, This is saying what number in the sequence do you want to find? For example, in our case, it would be the 50th number. Then it says I take the first number in the sequence, which would be 2. I write that down. Then I say in, like what's the number of, the place in the sequence. In this case, it is the 50th number. I subtract 1 and I multiply by the difference. The difference here is a positive 3. Okay, so let's see if we can figure out where this formula comes from. But let's do very quickly. Okay, so 50 minus 1 is 49. And here I have 49 times 3. 49 times 3 is 147. And 2 plus 147 is 149. So the 50th term in this sequence is 149. Now, where did this formula come from? Well, it comes from what's happening each time. Let's look at this sequence again. So I have 2, 5, 8, 11, and it just keeps going. I'm starting with 2. So what would happen if I wanted to say, what is, now it may seem silly, but what is the first term in this sequence? Well, I take the first term, that's 2, and I go, okay, I want to know the first term minus 1 times the difference, which is 3. Well, 1 minus 1 is 0. 0 times 3 is 0, so 2 plus 0. All right, that works. Now, what if it was the second term? The second term. What happens at the second term? If I was not looking at a formula, what's actually happening? It's 2 plus 3. Okay, our formula says a sub 1, the first term, 2 plus 2 minus 1 times 3. So 1 times 3. Because see, if it was the second term, 2 times 3, I haven't added 3 twice. To get from the first term to the second term, I add 3 one time. To get to the third term, I add 3 2 times. To get to the fourth term, I add 3 3 times. See the pattern? Second term, I add it once. Third term, I add it twice. Fourth term, I add it 3 times. I know I'm scribbling all over the place as I'm writing, but hopefully you're seeing that's why we say subtract 1, then multiply by 3, because that's how many times we add it. Now there's a secondary formula that is called a recursive formula. A recursive formula, as you're going to see, this is supposed to be just one word. This is a very fancy name for something that's very, very straightforward. So recursive formula is basically, you know how when I first showed you this sequence and said, okay, so we've got like, zoom in a little bit. It's like 1, 4, 7, 10. And we say, what comes next? You go, oh, plus 3, plus 3, plus 3. Ah, plus 3 is 13. Plus 3 is 16. Excuse me, allergies. That is what recursive formula is based off. It's basically saying you take the previous number and do something to it. In this case, add 3. And this is how it's written. Well, it actually has 2 parts. And it should become pretty clear why it has to have 2 parts. So, okay, so we have our a sub n again. And we say it's a sub n minus 1 plus 2. So if you have the 5th number, like a sub 5, then we would take 5 minus 1, the 4th number, and add 2. So that's all this is saying is if you want to know the 3rd number, take the 2nd number and add, and up here in this case would be add 3. But something's missing here. What is missing? Well, we have to know what the first number is. There has to be a starting point, right? So let's take the previous number and add 2. Take the previous number and add 2. Well, what's the first number? So recursive formula has 2 parts. It'll have this, and then it will also say what a sub 1 is. You know, that could be 5, it could be 100, it could be 50 million, whatever. It's going to have both of those parts. So for this sequence that we have right there, that formula, our a sub 1, would be 1. And we would say, you take the previous number and you add 3. And that's it. That's a recursive formula. You just have to know the first number and then what happens. You know, what happens to each subsequent number. It's pretty straightforward, right? I know the formula looks fancy, but it is a pretty straightforward thing. So let's take a look at a couple of, if they give you the formula, write the sequence. If they give you the sequence, write a formula real quick. So let's say I had okay, so here is our sequence. Can you write the 2 formulas for this? Well, here are our 2 little templates that we have to work with. Our sort of standard one is we have a sub 1 plus n minus 1 times d. And I'm going to scooch this over a little bit. And we also have the recursive version, recursive, where we have to write a sub 1 and then a sub n equals a sub n minus 1 plus d. All right, so let's just fill in the blanks. A sub 1 is what is the first term. Our first term is 5. So, okay. Oh, and down here, this one, I'm going to highlight these. The only things you need to change, right here and right here. Come on, let me highlight. Over on a recursive, you put the number here for the a sub 1 and here. That's all you need for both of these is what's the first term and what's the difference. And you just plug those in. So on the left side here, our first term is 5. We leave that n minus 1 alone. And our difference here is negative 3. I'm going down by 3 each time. Over on the right-hand side, a sub 1 is 5. And to get to the next one, you take the previous term and you subtract 3. That's it. Going the other way, what if they give you this formula and they say a sub n equals 12 plus n minus 1 times negative 2. And they want you to write like the first 5 terms. Okay, well, we know from our little template of this formula, a sub 1 plus n minus 1 times d, we know that this is a sub 1, or our first term. We also know that this is d minus 2. So we're going to be subtracting 2 each time. So if I'm writing the sequence, 12 minus 2 is 10, minus 2 is 8, minus 2 is 6, and so on. If I was given, scoot that over, if I was given the recursive formula, a sub 1 equals 7, and a sub n equals a sub n minus 1 minus 5. Okay, I know that whatever I'm given as a sub 1 is my first term. And I know the little formula. Whoops, I almost wrote minus 5 again. I know that whatever they tell me is a sub 1 is my first number, so I'm going to write that down. And I also know this d out here, that's my difference. So I know I need to subtract 5 each time. So 7 minus 5 is 2, minus 5 is negative 3, minus 5 is negative 8, and so on. And that's all there is to it. If you have any questions about this, please leave them in the comments below. If you have any ideas or requests for future topics, please let me know as well. Again, I'll be doing one on geometric sequences shortly, and when I finish it, I will leave a link below. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.